Hey, we're going to take a look at Olympiad 1, problem number 4. And this is a pretty tough problem. It reads, 2 pencils plus 3 pens cost 78 cents. But 3 pencils and 2 pens cost 72 cents. How much does 1 pencil cost? Now, you're probably looking at this thinking, oh, this problem screams algebra, because it does. You have 2 equations. And if you know algebra, that's a huge relief. On the other hand, if maybe you're one of the younger kids doing Olympiad and you don't know algebra, you're thinking, oh, I can't solve this problem. Maybe you'll use trial and error, and it would take a long time. It will probably work. But if we use some good judgment, we can actually make trial and error pretty efficient. Let's see if we can do that. Let's start by rewriting our English sentences into some math sentences. And our first stumbling block is that pencils and pens start with the same letter. That's a problem because we usually write variables based on the first letter. So I'm going to look at the words and try and figure out, well, what makes them different? And you see pen is in pencil, but this part, the N part, is different. The C and the I and the L are all unique letters. For me, I just like the letter L, so I'm going to write 2L plus 3N for the pen, because the N sticks out in my mind. You can pick anything you want. And then I'm just going to keep it the same. So over here it's 3L plus 2N is 72. Whatever we come up with has to work for both equations. So far, so good. Now I'm going to inspect this for just a minute and ask myself, what can I get? If I were Sherlock Holmes, what would I learn from these 2 sentences? And I would start by saying, well, when I got 3 pens, it's 78 cents. When I've got 2 pens, it's 72. I probably know that the pen is greater than the cost of the pencil, because when I've got 3 pens, it costs more. That's probably true. Also, when I've got 5 of these items, the prices are different if the numbers of items are different. In other words, even though I have 5 things up here and 5 things down here, it's not the same price, which means the price of the pencil does not equal the price of the pen. So I can eliminate that right away. So these are 2 clues that will help me think about my answer. Looking at it again, I see that I've got 2 of something and 3 of something, and I've got to group them together such that the last digit is an 8 or a 2, and that it sums to 70. So 2 items where the last digit is either an 8 or a 2. And I can take, there are only so many ways to actually get a 2 for last digit when you're adding numbers. And only so many ways to get an 8. You could do, for example, a 7 and a 1, a 6 and a 2, a 3 and a 5, a 4 and a 4, or an 8 and a 0. Those are the only ways to get an 8. And with a 2, you've got a 2 and a 0, and a 1 and a 1. That's it. Those are the only ways to get 2. So this 2 is really restrictive. That actually might help us a lot being able to work on these problems. Now some of you might be thinking, well, couldn't you add 2 digits together to get the 2 or the 8? And it turns out you could. You could get an 8 if you had 2 9s, but we know that the digits that could potentially work. So I'll make a little note of that, maybe with 2 9s. And likewise with the 2 6s could give us 12, and there are a bunch of other numbers that could as well. So as we go through, this is our frame of reference. So I'm going to make a list of 2 of something. I'm going to make a list of 3 of something. And we're going to take a look at those lists to see if we can figure out what we think the cost might be. So I'm going to start thinking of starting at a small number, like let's say 8. So my list would be 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. That's a little list of 2s. A little list of 3s. Let's start with 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51. So here we've got a list, and we can take a look at some of these possibilities. We know that 5 things into 78 would have an average of right around 15.5. So if they were all equal, it'd be around 15. So we might want to start with values closer to that. So let's start with, let's even start with 15. Let's take a look. So if we have 2 of 15, so let's look at some combos here. 15 and 3, we need an 8. Do we have any 8s? 18, well that wouldn't work because 30 plus 18 is 48. That's not enough. We need much more. 48. 30 and 48, that would work. 2 of 15 plus 3 of 48. 3 goes into 48. Let's check. 19 times? Is that right? 16 times. 15 and 16. Okay, so that would work for the first equation. In fact, I'm willing to bet most kids stopped at this point, thinking, oh, that's perfect. If we reverse it and we do 3 of 15 plus 2 of 16, we get 45 plus 32. That does not work. So that's a pretty good possibility, but it's not going to work. In fact, it's much too large. 45 and 32 is going to give us 77. It's over by 5 cents. So maybe we should try some smaller values. Let's take a look at, so we can get rid of that because it doesn't work for both. Let's try 28. 28 would need 50, not on our list. So I'm just going to cross that off. 26 would need, let's do 78 minus 26 to 52. Is 52 on our list? It is not. Let's take a look at 24. 78 minus 24, 8 take away 4 is 4, 54. It could be on our list actually if we went down one more. So let's explore 54 for a second. 3 and the 54 is 18. Okay, so what I'm going to do just to make a little room, I'm just going to erase this really quick. I'm going to erase this, give us a little more room. On your paper, it'd be like you just made your paper longer. So we said 2 times 12 plus 3 times 18. 2 times 12 is 24 plus 54 is 78. So now let's look at 3 times 12 plus 2 times 18, 78. 3 times 12 is 36. 2 times 18 is 36. That is, in fact, 72. So a pencil costs 12 cents, and it works for both equations. So this is one simple way to build a list looking at combinations of numbers using the last digit to help us figure out, could we get this to work? And the reason this is a better strategy than just pure trial and error is we use the last digits to help us decide if a number was even possible. So yeah, super tricky problem, but there are ways in using logic that can make sense. And hopefully you'll be able to use some of those strategies on an Olympiad. Hope you had fun. Talk to you soon.